In this video, we're going to talk about the basics of geometry. We're going to have a lot of vocabulary, theorems, postulates, and other really helpful skills to help us solve problems throughout this unit and throughout this course. So our first term is an angle bisector. And an angle bisector is a ray that divides an angle into two congruent angles. So, given my drawing, if the ray CD is an angle bisector, then angle 1 is congruent to angle 2. Notice the symbols for angle. You can also write it without my measurement arc. It is the same thing. And then my congruent symbol. The next term is the midpoint, a point that divides a segment into two congruent segments. So, given my line segment AB, if point C is the midpoint of segment AB, then segment AC is congruent to segment CB. And we can mark that in our drawing using a tick mark to show this length is congruent to this length. Going back to the angle bisector, we can mark these angles congruent by using a 1 arc to show that this angle 1 is congruent to angle 2. Our next term is a segment bisector, a line, ray, or segment that intersects a segment at its midpoint. So, if the segment CD is a segment bisector of the segment AB, then point E is the midpoint of segment AB. Now, when I say if segment CD is a segment bisector of AB, that is at the point E, which makes the point E the midpoint, which, from what we know about the definition of a midpoint, makes the segment AE congruent to the segment EB. So in this example, the segment AE would be congruent to segment EB. Our next term are perpendicular lines. Lines that intersect forms a right angle. So, if the line AB is perpendicular to the line CD, then the measure of angle 1 is 90 degrees. And notice my symbol for perpendicular looks like an upside down T. Our next term is supplementary angles. Two angles whose measures have a sum of 180. So if angle 1 and angle 2 are supplementary, then the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Our next term, complementary angles. These are not angles that tell each other they look good in the morning. They are two angles whose measures have a sum of 90 degrees. So if angle 1 and angle 2 are complementary, then the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Next, we have what's called the linear pair postulate. If two angles form a linear pair, then they are supplementary. So if angle 1 and angle 2 are a linear pair, then they are supplementary, which means the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Our next term are vertical angles. Non-adjacent angles formed by two intersecting lines. The theorem for vertical angles are congruent. So in this example, angle 1 is congruent to angle 2. I would like to comment here that I am saying that the angle 1 is congruent to angle 2, not the measure of angle 1, because the measure implies a number, and numbers are equal. Objects, such as angles, are congruent. It's a slight little detail that we do have to pay attention to when solving different problems. The next term, or theorem rather, is the right angle theorem, which says all right angles are congruent, which, when you think about it, in terms of perpendicular lines, so let's say the line L and M are perpendicular, making angle 1 90 degrees, and then would make angle 2 90 degrees, then angle 1 is congruent to angle 2, which we can mark this using our 90-degree box symbol. Now, for the last three theorems we're going to talk about in this video, we're going to use this figure where the lines L and M are parallel. Notice the symbol I use here, L is parallel to M. And parallel lines, which most of you know, never cross, never intersect, but continue in the same direction. And T is a transversal line. And transversal is just a term we're using here for the line that's cutting L and M. So, using this, we have what's called the alternate interior angle theorem. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. So looking at our diagram, the alternate interior angles, interior being inside the parallel, alternate being opposite, so opposite of the transversal, would make angle 2 congruent to angle 7, and angle 6 congruent to angle 3. The next theorem, alternate exterior angle theorem. Alternate being opposite and exterior being outside the parallel lines. If parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So once again, looking at our diagram, the alternate, so opposite, exterior, so outside the parallel, are congruent. In this case, making 1 and 8 congruent, so angle 1 is congruent to angle 8, and angle 5 is congruent to angle 4. The last theorem is the corresponding angle theorem. If parallel lines are cut by a transversal, then the corresponding angles are congruent. So think of the corresponding angles as angles that are matching up together. So, in our drawing, corresponding here would be the angles 1 and 7. So we would say the angle 1 is congruent to angle 7, and angle 6 is corresponding to angle 4, making them congruent. Angle 5 congruent to its corresponding angle 3, and angle 2 congruent to its corresponding angle 8. I realize this is a lot to take in, but now that we have these notes, we will move forward in class and do various different activities to solve problems and identify the various terms, definitions, and theorems we have here. Thanks for watching.